Hello guys, welcome back to the channel for another Azure video. Today we are going to play around with Cosmos DB and the Core SQL API. According to the documentation, Cosmos DB is a globally distributed multi-region and multi-API NoSQL database that provides strong consistency, extremely low latency and high availability. Now, I don't have enough experience to be called an expert in NoSQL databases. I used MongoDB many years ago for a Java project when NoSQL databases were not that popular or advanced. But since I switched to data engineering, I've been using only relational databases. The cool thing about Cosmos DB is that it provides multiple APIs to query the data. Core SQL API is the most common one, especially if you're coming from relational databases. It is very intuitive. You write queries in a similar fashion with SQL queries, which is amazing because you don't need to learn something completely new. It's so easy to get data from a JSON file. If you have used SQL to parse JSONs, you are aware it's a bit fussy to get data out of a JSON or to create a JSON. Another cool thing about Cosmos DB is that you can trigger Azure functions among other things, but we will do that in another video. Last but not least, you can implement CRUD operations and manage your containers and your data in Cosmos DB using our very favorite language, Python. So how cool is that? I already like Cosmos DB. But enough talking. Let's see the basic concepts of Azure Cosmos DB. As we mentioned, Cosmos DB provides several APIs. The main one is the Core SQL API that we will see today, which resembles that of a document data store using JSON. Then we have the MongoDB API, which is ideal when you have MongoDB applications and you want to migrate to Cosmos DB with minimal implications. The Cassandra API, the same concept is like Mongo in the fact that migrating Cassandra-based apps is very easy. Then we have the Postgres API. This is ideal for starting on a single node database with rich indexing, geospatial capabilities, and JSON-B support. Table API. Many designs and apps in the real world use table storage. There are many limitations with table storage, so this is a nice option when you have problems with low latency, high throughput, and consistency levels. And the last one is Gremlin API, a great way to see graph-based use of your data in the form of vertices and edges. Moving on to the basic features of Cosmos DB, we have elastic scale. So you pay for Cosmos DB via a combination of storage and request units per second. One request unit is the CPU, disk, and memory required to read 1 kilobyte of data in 1 second. So as your business grows and your requirements are more demanding, simply you scale up via Azure portal or automatically. Global distribution. Globally distributed applications need a globally distributed database. So we replicate the data anywhere on this planet so the users have a copy of the data close to them. Azure Cosmos DB allows you to read and write data from the local replicas of your database. Then we have low latency. Cosmos DB supports 5 consistency levels: strong, bounded staleness, session, consistent prefix, eventual. The options provide a spectrum of high availability, latency, throughput, and cost. So the stronger consistency, the more latency you have. On the other hand, if you choose eventual, it would be very fast, but you would have low consistency. Apparently, you have to choose based on your needs, right? Another feature of Cosmos DB is change feed. The change feed in Cosmos DB is a persistent record of changes to a container in the order they occur. Change feed support works by listening to a Cosmos DB container for any changes. These changes include insert and update operations made to the items within the container. But the cool thing here is that you can create small reactive Azure functions that will be automatically triggered on each new event in your Azure Cosmos DB container's change feed. I think this is a very, very cool feature. Let's take a peek at the elements in Azure Cosmos DB. We have a database account, a database, and a database has containers. Now, as you can see in the diagram, a container has items, merge procedures, conflicts, triggers, user-defined functions, and store procedures. For me, it helps to think containers as tables and items as records inside those tables. Depending on the Cosmos API, a container is realized as a collection or as a table or as a graph. And the items, depending on the API again, are realized as documents, rows, nodes, edges, etc., etc. If you use Core SQL API, I believe it's very easy to imagine containers as tables and items as the records in those tables. Because as an item, you will have a document, but the document actually represents a record in a table if you had a relational database. I think it's an easy transition. Now that we have a basic understanding of Cosmos DB features, let's create a Cosmos DB ourselves. So in the Azure portal, search for Cosmos DB, click here, Azure Cosmos DB, click on create, and as you can see, we have 6 Cosmos DB APIs, the 6 APIs that we just mentioned before, the Core SQL API, the Postgres SQL API, the MongoDB, the Gremlin, and the Table API, the Cassandra API. For our demo, we are going to use the Core SQL API. As you can see here, it's the first one and it's the most popular one. It supports fast, flexible development with familiar SQL query language and client libraries for .NET, JavaScript, Python, and Java. So click on Create here, select your resource group, enter an account name. I am in West Europe, so that is here. Provision throughput, that's fine. Apply the free tier mode, yeah. Global distribution, now we leave everything as it is. Review and create. This will take a couple of minutes, so just be patient. I will come back once the deployment is done. The deployment is completed, so click on Go to Resource, and here we have our Cosmos DB. Under the Quick Start blade, Microsoft guys were polite enough to provide, an easy way to start our development. First, you choose the platform, Python. For us, it will create a container here. So click on Create Items Container. It's going to create a container with 400 request units per second, which is the minimum requirement. It created an items container, so with 400 request units for capacity. And now we click on the download here, and this will download a zip that contains 3 files, 2 Python files, and the requirements.txt file that has the dependencies. Before I open those files, though, if we scroll down on the left panel, and we will need, in order to connect to our Azure Cosmos DB, we will need to have the URI and the primary key. So here, click on the keys blade and just save this URI and the primary key because we will need it in VS Code in order to connect to Azure Cosmos DB. So let me switch to VS Code here. Here we have the 3 files, run.py, the config.py, which contains our settings, and the requirements.txt, which contains the dependencies for our libraries that we will need for this example. Now under config.py, you will see the settings. Here for account host, you will see this is the URI that we found on Azure portal, and the account key is the primary key. For database ID, we have the to-do list, and the container ID is items. Here under run.py, first we have to import all the dependencies, of course, and in order to run this code, we need to install all the libraries. So just type pip install -r the requirements txt. I have already installed the dependency, so that's fine for me, but you have to do that before you run the code. And this run.py file is a perfect example that demonstrates the basic CRUD operations on an item resource for Azure Cosmos. We have to thank the Microsoft guys here because it's very easy to start development when you have already, uh, when you have already this code to perform the CRUD operations, which is a tedious process usually. If you scroll down to the run sample function, you will see first we need to establish a client that uses the host and the master key in order to connect to Azure Cosmos DB, and then using this client we create a database providing the database ID that we have in the settings. Of course, if the resource if this database already exists, we will print it or throw an error. In other cases, whatever you want. We have to set up the container. Again, we create a container based on the container ID we provided in the settings, and we have to also define the partition key. So here, as you can see, the path is /partition key. So in the JSON, in the document, in the JSON object, let's say, it has to go, the path to find the partition key. Like, let me show you. If you scroll up a bit, you will see here a JSON, and here, as you can see, it has partition key as an attribute, and this partition key here is this is the partition key that this path is referring to. Let's see the functions here. We have the scale container, so let's see how we actually perform scaling. Here, let's say we want to scale up the throughput. We pass the container in the function, we read the offer, and then we increase the throughput by 100 and we'll replace the throughput. So that will increase the throughput from 400 RUs to 500. 400 is the minimum, it doesn't go lower than that. So that will now be, after we run the code, it will be 500. The next thing we are doing here is to create items in the container. So it has two functions, one for the sales order and provides an ID. And here, if you follow the function, you will see we create a JSON file with all those attributes, the array here, etc., and we pass the item ID. As you can see, we have already defined the partition key, but this is just an example. This is how the code works. Here in this case, we can, of course, define our own partition keys in our code. And then we have the get sales order v2, the same thing. Again, we have added two more attributes here, due date or ship date, etc., that cannot be found in the first JSON because it's schema agnostic. We can add or remove new fields from the JSON, and it's not going to give us an error, right? Which is awesome. Now, if you scroll to the right a bit, you will see the comments that the Microsoft guys wrote. And here, this is a typical, as they say, this is a typical refactor that happens in the course of an application that would have previously required schema changes and data migrations. This makes our life pretty easy, right? We don't have to care about those stuff because it's schema agnostic. Then we read an item. There is a function called read_item. We provide the doc ID and the partition key, and this will read the specific item with this ID. But we also have the read all items function here, so that gives us a list of all the items in the container. As you can see, there are many comments here that you can check out yourself and understand the code better. We just go through the code to understand the basic things. Query items, again, it's like querying a MySQL database from Python. Nothing new, you provide the query and the parameters. Pretty cool, I would say. Easy to adjust. And we have the replace item here, this replace function, which is essentially updating a record. Let's say we get this attribute here, subtotal, we add 1, and then we replace the item, which is like updating in the database, or upsert item. If the item does not exist, then we insert, otherwise we update the item. And of course we have the delete item function here when we provide doc ID and the partition key. Let's run the code, but first let's comment out this line here and this line here, because this is going to delete the database. We are going to do that in the end, but for now let's save that and run the code, see what happens. Perfect. So we created a database called to-do list and then a container called items. Then we scaled the container, so we increased the throughput. It was 400 RU, now it's 500 RU. We created items and we read item by ID, so that returned the sales order 1. But we also read all the items, so you can see the item ID here, sales order 1, sales order 2, and then we queried the item, we replaced the item, and you can see the new subtotal after replacing or upserting an item. And we didn't delete anything because now we want to go to Azure portal and check our data. Click on the Data Explorer blade here on the left panel and expand the data. So you will see this database here, to-do list, and a container called items. And if you click on items, you will see 2 items here with the ID and the partition key that we provided. So let me expand this a little bit, and here if you click on this item, you will get to see the item here, the JSON file, the JSON data that we inserted using Python. By default, it is adding all those extra field here for metadata, etc., etc. And this is the second item. Now, as you can see here, this is the query that we are running right now to select everything. But you can also, click on filter from c.id equals sales order 1 and click on apply filter, and this will give you only the first item, right? So here you just edit the query, or in fact you can create your own query here. Click on the new SQL query and just run your query, right? And this will give you the same the results. Now under query stats, you can see the value of the request charge here, that we were charged 2.28 RUs for this query. Apparently, the more complex the query, the value here will be larger. It depends on the complexity. So if you apply many filters and joins, etc., it's going to give you a larger value. It's going to charge you more. We can add new items, of course. So if you click on items, then click new item, then just use that as test 1, 2, 3, let's say. Click on save. This is going to create a new item with this ID and this new extra fields, and here you will be able to find it if you query the data again. Select everything and you will see the first item, the second item, and the third one that we just added using the SQL editor, of course. Now let's run a couple of queries and see, how you can. The syntax is a bit, it's very intuitive. It's a slightly different than the normal SQL syntax, but as you can see here, you can select from these items container where the partition key equals to account 2, and that will return you this the respective JSON, right? If you check the query stats, you can see the value increased because we added a where clause here, and of course, depending what column you're using in your where clause and in your joins, that will, you know, uh, increase or decrease the value, the request charge, because apparently using the partition key, it would be much easier to query the data than using another column. So here, as you can see, there is, let's say we want to get the tax amount and the product ID from account number 1. Now, tax amount is here, but then the product ID is in the nested items array here, so we want that, and that here. Perfect. So what we have to do is actually join with our items, let's say our dot items, this array. We it's like creating a new table. We just reference it as C, and then we add the where clause. So if we click on execute, you will see now we are going to get the tax amount and the product ID back. This is the only difference I've noticed, the main difference I've noticed. But the cool thing here is that you can actually get, you can actually read from an array the first item or the second item, whichever you like, and get the price of this respective item. It's like using Python in a way. It's weird to to explain that. I think you have to play around to understand what I'm talking about. Then we have let's say these parentheses here in order to structure our own JSON. And if you run this, we have an item, and then tags and tag ID new, etc., etc. You can use also brackets for an array. If you select that, it will give you an array back. You can use aggregate functions like sum. If you want, you can see the parentheses here. If you want to remove the parentheses, you can use this select value here, and this will give you just the value, right? A very common scenario, apparently, if you are an ETL developer, is check for duplicates using a count star and like a group by and halving clause. Now there is no halving clause here in this language, so you have to use an outer query, select from, you perform the group by in the inner query, and this will give you that. Let's say now this query doesn't apparently make any sense, but just to I want to mention that you have to use an outer query. You perform the group by in the inner query, and then you use a where clause in the outer query to check what you want, to check for duplicates, etc., etc. As you can see on your own, it's a very intuitive language, especially if you are coming from a traditional ETL data engineering background where you use relational databases. I don't think I have to explain any more here because it's very easy to understand. I think you have to play around with it yourself. We can see the features here. We have the features. They replicate data globally. Remember that we mentioned that you can replicate the data wherever you want in the data center all over the planet. Then we have the consistency. Now the default is session consistency, and this gives you a better understanding of what consistency is in other parts of in other data centers around the globe. You can choose between all of those options: strong, bounded, staleness, session, consistent prefix, and eventual. We have the network settings apparently and the keys. We can integrate Cosmos DB with Power BI, Azure Synapse, Azure Cognitive Search, and Azure Function. Now it's the change feed element that we mentioned before that is pretty cool, and that will trigger an Azure function whenever you have a change in your container. That was a quick overview of Azure Cosmos DB and how to use Core SQL API. Apparently, all the work was done by the Microsoft guys that we have to thank them because they provided the initial code and we can start developing right away. We don't need to do much, and we can use Python and also the SQL editor here in Azure portal. It's pretty cool. It's pretty flexible. This is it for today, guys. I hope you enjoyed the video and you found it helpful. If you like the video, please click the like button and subscribe to the channel, and I will see you in the next one. Thank you.